Welcome back. This is section 4.1 Real Vector Spaces. In this section or throughout this course, scalars mean real or complex numbers. They will be denoted by lowercase letters C, D, R, S, T, A, B, so on, but just lowercase letters. Vectors are quantities with magnitude as well as a sense of direction. Vectors are denoted by bold-faced letters, typically U, V, X, Y, Z. To form the rectangular coordinate system or a Cartesian coordinate system, named after René Descartes, what do we do to draw a rectangular coordinate system? What you do is draw a pair of perpendicular lines. Intersection of the lines is O, that is 0, 0. It's called the origin. One line is placed horizontally, is called x-axis, and the other line placed vertically is called the y-axis. Consider the following. So that is your x-axis, that is your y-axis. A directed line segment. So segment, that is, it has finite length. It's directed because you see an arrow there. It's called a vector. Okay. In this case, we have placed the vector at origin. Vector O to P with an overline arrow. Notice the arrow. That's how you denote vector from O to P. It has tail O and head P. Okay, so the arrow point is called head. The starting point is called tail. The magnitude of this vector, magnitude of the vector is its length. In this case, length of the vector is distance from the point 32 to the point 0, 0. You see? So I have just used the distance formula, square root x1 minus x2 quantity squared plus y1 minus y2 quantity squared. So you see this point is 0, 0, this point is 3, 2. Difference in x coordinates squared, difference in y coordinates squared, add them up, take the square root. Thus the distance from origin to P. In other words, that is the length of the vector or magnitude of the vector. Suppose you have two vectors u, x1, y1 and v, x2, y2 with tail O being the origin. Then these two vectors are said to be equal if x1 is equal x2, y1 is equal y2. Example, here are two vectors, a minus b3, 4a plus b. They are equal if and only if a minus b is 4 and 3 is a plus b, or a plus b is 3. Well, we can solve these two equations in the system of two equations. You simply add these two, you get 7 here, 2a here, 2a is 7, so a is 7 halves. Moreover, b can be obtained from the second equation, b equals 3 minus a. Alright, so 3 minus 7 halves, that's negative half. Sometimes we encounter vectors of the kind TH, T for tail, H for head, vector with tail T, head H, where tail is not the origin. What happens then? We call such a directed line segment as a vector with tail T. Okay? The components of such a vector are x2 minus x1, y2 minus y1, where tail is x1, y1, head is x2, y2. It should be y2. What does that mean? All we are doing is head minus tail. Those are the components. Components are head minus tail, head minus tail. Okay, so here is an example. Here is a vector A with tail 1, negative 1, head 4, 1. Here is a vector with tail, origin and head 3, 2. Here is also a vector, tail negative 2, negative 2 and head 1, 0. But notice all the three vectors are parallel to each other, and from the looks of it, they have the same magnitude. So they should be the same vectors as vectors, or their components must be equal. So let's figure out this one. This vector has component 3 minus 0, 2 minus 0. In other words, that's 3, 2 is the component of this vector. What about vector here? 1 minus minus 2 is positive 3. 0 minus negative 2 is positive 2. So this vector also has components 3, 2. What about this vector? 4 minus 1, 3. 1 minus negative 1, positive 2. So they have, all the three vectors have the same components. All the directed vectors in this case are equal. When the components are equal, you say the vectors themselves are equal. So head minus tail, head minus tail, head minus tail, head minus tail. Okay, so those are the components. Two vectors are equal if and only if they have equal magnitude and equal direction. That is, when we write a vector x, we mean the vector, so x vector is little x, little y. When we say just in this form, what do we mean? We mean the origin is your tail. You always start from origin if you are simply given the coordinates of a vector. Okay, so if you are given, these are not called coordinates, they are called components of the vector. Okay, so therefore you may consider coordinate plane in two ways. Coordinate plane consists of all points. So coordinate plane is a set of all points. Or you may view it as set of all vectors, because a point, any point, gives you a vector starting from origin. Okay, so you may view coordinate plane both as set of all points or set of all vectors. Sometimes we write a vector as a point and sometimes as a column matrix. So how do we add two vectors? So you may think of this as a point or as a column vector. Suppose you have two vectors, u and v, and their respective components. U is u1, u2, v is v1, v2. How do we add? Exactly as you would expect, u plus v, the vector u plus v is u1 plus v1, u2 plus v2. Note, vector addition is simply addition of matrices. Example, vector 4, negative 2 plus vector 2, 3. 4 plus 2, 6. Negative 2 plus 3, 1. So here is 4, negative 2. Here is 2, 3. Okay? 4, negative 2 and 2, 3. Their sum turned out to be 6, 1. So look at the picture. 6, 1 is here. So what's happening? 4, negative 2 and 2, 3. There seems to be some relationship, isn't there? This is the relationship. It is the geometric way of adding vectors. 4, negative 2 and 2, 3. What do? Given these two vectors, complete the parallelogram. In other words, draw something parallel to 2, 3 over here. Draw something here parallel to 4, negative 2. You see, so that gives you a parallelogram. The diagonal starting from origin is your resultant vector. Geometrically, what this means is you're going along this path to 4, -2, and then going up along this path. So what is this path? As a vector, this vector is equal to this vector. So in essence, you have added this vector to the vector 2, 3. Okay, and that's why you have landed here. Another way of thinking, you start walking along this path and then add this vector 4, -2, and you land in this location. So remember, if I have the same length and direction, the vectors are equal. So opposite sides, they both go in the same direction, so they are equal vectors. These two are equal vectors as well. Okay. In general, we have the following picture. You have vector u1, u2, and you have vector v1, v2. You complete the parallelogram made by these two vectors. So what does that mean? Take this vector, draw a parallel line segment, directed line segment, starting at the end of the first vector. You land here. Likewise, take this vector, draw something parallel to it, starting with this tail, and go here. You get a parallelogram. From the origin, the diagonal drawn is the sum of these two vectors. Okay? Similarly, consider u equals 2, 1. What happens to u? That is 2, 1. So notice, if you're just given a point, assumption is the tail is origin. That's 2, 1. Look at 2 times u. 2 times u is 4, 2. So it's the vector in the same direction going in this direction. 4, 2. Same direction as u, double the magnitude. What about -2u? It's in the opposite direction. That's what the negation does. Opposite direction and twice the magnitude. So that's -4, -2. Scalar multiplication. This is what we just saw. You saw this vector, multiplied it by 2 or -2. So scalar multiplication, given vector u1, u2, and any scalar. Remember, scalar can be a real number or a complex number. Let's just work with real numbers because we are looking at real vector spaces. We define scalar multiplication as just take the vector, multiply it by c. In other words, you are multiplying every component by c. If c is greater than 0, that is, if c is positive, then cu is in the same direction as u. If c is negative, then cu is in the opposite direction as u. What happens when c is 0? Then cu is the 0 vector. If I multiply something by 0, all I get are 0, 0. Okay? Here, what is the 0 vector? It's denoted by boldface 0, which is 0, 0. It is the origin. Okay? Thus, for any vector u, we have u plus 0, 0, that is the 0 vector is u. U plus -1u is 0. -1u is called the negative of u or the additive inverse of u. Denote the negative u, that is -1u by negative u. So notice this is a notation. -1 times u is denoted by negative u. Okay? The difference between v and u is v plus -u. It is denoted v minus u. Okay, let's continue with the examples in our next video.